Okay, so the project itself is written in Python. It's the one of them like popular programming languages for AI applications. And we have chosen this because it's there is a lot of libraries that can help us with like third-party integrations, but also overall it's a good programming language. And so the main app, it's located here in the back. And currently how it works, it has, the idea is you integrate data sources, and then between your data sources and you as a user, there is this AI agent that you can talk to about your data. You can ask it to add some data, or you can ask it to retrieve some data. You can ask to update, delete, basically do any operations. Plus, on top of that, if you ask any questions like not related to search, but in general questions, please recommend me something like weekend activities, or I don't know, some writing something. It will use your current knowledge that you have from your data sources to generate that answer. So it's not only chat about your data, but also use your data to ask your questions. And the architecture itself is separated into these layers. And I got this idea from clean architecture principles. It's not yet fully clean architecture, but I got the main idea from there, and we will refactor this code base to make it more and more agnostic from any third-party implementations like providers, agnostic from databases, from storage providers, from LLM providers. And in that way, it will be the core business logic will always stay the same, but only the providers will change. And anyone within this community can easily integrate, add, remove any like data provider they want, or any LLM provider they want, sorry, AI provider they want. That's the whole idea. And as you said, it's already working as it is. It does the things that we discussed. And we started first by separating or abstracting the data sources. So as you can see here, I have this folder adapters, and this is where it starts. So from here we have this embedder service, and embedder service, it's the one that generates the embeddings. So when you ask question, your query or your prompt, it's converted into this embeddings format, and then behind the scenes it uses this embeddings to search from the vector store. Then there is GraphDB provider, adapter, and currently we use Neo4j, and it's wrapped in our own class adapter. So in the future, as you can see here, we use Neo4j graph. In the future, if you want to switch from Neo4j graph database to something else, or to your own Neo4j, or to some other graph database providers, all you do is you change here the connection to Neo4j, and the query method will always stay the same. So you don't have to change or rewrite the whole app, because now this app is dependent on this wrapper around implementation. So it's like abstracted. So this is the whole idea that we currently did. And same, it does the same for this vector store. As you can see here, we are wrapping now around Supabase adapter. We can generalize this more like just saying vector store adapter. So that the implementation currently is with Supabase, but user or anyone else can switch between different provider here. And of course, if the method like adding document to this vector store is something different, they will have to write this implementation here. But the whole app, it's still going to work the same. They don't have to touch anything else. So that's the whole idea in terms of what it is now.
So it's designed to be modular, right? So you can swap in and out different databases, et cetera. It's not meant to be a fixed thing, but it's meant to be open from an architecture standpoint, so you can use whatever you want within this framework, right?
Yes, correct. And maybe the easiest way to explain this Now, usually when we started writing this code, the prototype of this memory, I would say agent or memory app, the app was dependent on Neo4j graph. It was using their libraries, it was using their queries, or any implementation that Neo4j provides. Now, the app itself, it doesn't know which graph database you use, and it doesn't care. It doesn't care if you use Neo4j, it doesn't care if you use any other graph database. All it cares, it knows only this, that it has this wrapper, and this wrapper has this query method. That's all app needs to know. It doesn't care about the implementation. That's the first step, like refactoring step that we did. And now anyone within developer community, they can switch. I think they still will be using Neo4j, but they have now option to switch between different providers and also implement or add additional data sources. So that's what it is now.
Great. And do you want to talk a little bit about the different pieces of this? Like we have the LLM that you're chatting with, the embedding model, the vector database, the knowledge graph, all the different components that we have currently?
Yes, correct. So on top of that, like we have here this adapters, and this is the actual where we, maybe you can guess from the name, this is the actual where we write the integration part with the actual provider. And then we export everything that's from here, from adapters, we export it here to data source manager. And then app calls get graph database or get vertex AI search or get vector search. And what this does. So we have three sources of data, three data sources. One is graph database, the other one is vector store, and the third one is vertex AI search, or previously it was known as enterprise AI search. So these two, the first two, agent can perform all operations like add, update, delete, and get. From this vertex AI search, it can only read. It cannot add, it cannot update. It can only retrieve information, and it's fine for our use case. And let me show you one example of the tool. Okay, let's get in here, search tool. So this is, as I said, the app is designed in this way. You have data sources, and then between these data sources and user, there is this AI agent. And you can interact with your data sources using conversation. Like you don't have to know the programming languages or write this SQL queries or graph cipher queries to add something or to retrieve something from your data sources. You can chat to this agent and it will do the job. And this agent has tools. And this tool, for example, called search, it means it's going to search for any relevant information from your data sources when you ask a specific question or when agent decides that it needs to search for context. And as you can see here, we defined three methods. So we have vector search, vertex AI search, and graph search. Now, if for any case, now it's depends. The search gets information from three sources, from vector search, vertex search, and graph search. If user or anyone else, for example, they don't have vertex AI search, it's fine. They can come here, delete these lines when it searches for this vector search, and that's it. So they don't have to, their tool doesn't have to search for vertex AI. Same true for graph search. If they don't have Neo4j or they don't want to use, all they want is vector search, also fine. Just remove this graph and vertex, and that's it. It's going to work with only one data source. And same is true for other tools. As you can see here on the left, I have these subfolders within this tool directory. So we have add, delete, document search, get all, search, and this update. So the same logic, it's within all of these tools.
Right. You can change it and you can make it what you want it to be, or you can use it out of the box as we've designed it, right?
Yes, correct.
Okay. And
In
you
terms of future, sorry, I'd like to add something here.
sure.
This is not yet ideal and it's not yet perfect in terms of this switching, like making it easy to switch and add, because now you have to, it's not yet fully centralized in terms of what we have this file and the search tool exports this, where is it? And the search tool exports it from this file, from data source manager. In the future, we'll make it much simpler to implement, and it's going to work all based on one config file. So before you start running this app, there will be this config file where you can, I already started doing this. So as you can see here, if user provides, if this is empty, for example, if this is going to be empty, then this app wouldn't search from Graph database, and it won't use Graph database provider. Same is true for vector store, but at least only one data source there must be, and there, I think we can leave it default as a vector store. But in the future, this is how I see it. User configs this file, settings.py, and anything they put here, app will use it or don't use it.
Great. So in terms of the components of this, you have the agent, right, that you've developed that is deciding when to add things to memory and when to inject things from memory into conversations, correct? That's like one of the core pieces of this, yes?
Yes.
And can you talk a little bit about how that was put together?
Yes, sure. So again, here, these agents are separated into this folder, and we are using LangGraph AI library to help us build the agent. And here we have this function wrapper, which is called invoke our graph, which means invoke our agent. And here where we build the agent. And basically now this agent, the components of the agent itself is very straightforward. You provide the AI or the intelligence, and you can use any AI provider you want, which LangGraph supports, and LangGraph supports many LLM providers. You provide list of tools or actions this agent can perform. Currently, this is our tools that our agent can do or can perform. And then you provide the system prompt. So here's the system prompt. So it's like 3 customization that anyone can do. If user wants to use OLAMA, for example, they can switch it from this LLM adapter, implement this OLAMA integration there, import it, and that's it. Replace it here. It's going to work. If they have Anthropic, same true for Anthropic. Implement it in LLM adapter, import, and use it here. With tools, they also have option flexibility to add, implement their own tools. You can implement them using LangChain and LangGraph. They have very straightforward documentation. I mean, in terms of if they want to add additional features, additional actions to their agent. This is the default that we defined. And same, another customization is with with system prompt. And the system prompt, I have separate folder here called agent prompts. So there is default prompt, which will be included in this repository on GitHub. But it's good enough to start with this prompt. But as anyone will use it, they'll have to customize it for their use case. And we can share your example. This is custom prompt, and I included your name and some information. I think your business name too here.
I don't see
So
that. That screen's blank. Oh, there we go.
yeah, you should see it now.
Yep. So we've been working on this for me personally, and we're sharing the prompt that you've developed for me, correct? Within this as a starting point.
No, I'm sharing. There is default prompt here. This
Yep.
default prompt is going to be available on this repository on GitHub.
Yep.
It's good enough to start with. Your agent will understand uh, all these tools and actions it needs to perform. It will understand its how to say purpose. So it will understand its purpose and follow instructions. But if you want to make it personalized, they will need to adjust it or tailor this prompt for themselves. So there is another example that I'm showing. This prompt, custom prompt, I guess it won't be included there, but this is just as an example how it can be customized because this prompt is customized for your use case.
Yep. And we can share this, a document with this in it as, in the description of the video so people can get a sense of how we're customizing the prompt and then how they may want to tune it. And it may depend, like we're using ChatGPT 4.0 for our LLM that we're chatting with, correct? Or
For LLM, it's 4.1.
4.1. Okay. So if someone wants to use Anthropic or an Olama model, for example, like they'll probably have to tune the prompt to work with that model specifically. Yeah.
Yes. So yeah, correct.
Okay. So we have the agent prompt, and then what else do we have?
Okay. So to build the agent, it's three components. The intelligence, it's the brain, and it determines how smart this agent will be. If you use some like models like 4.0 mini, for example, it will be good enough, but you will notice that sometimes, okay, you know the outputs quality between these different models, so we don't have to explain this. So the first component is the LLM, the intelligence. Then second component is these tools or actions this agent can perform. And third customization is the system prompt. It's basically your instructions, how this agent should behave, uh, what it can do or can do. And maybe another customization or personalization that users can do here in the system prompt, they can provide examples of what type of information it needs to automatically put in your database. Because now it works when you explicitly tell it, please remember this, or please add something. It's going to add it to this data source providers, but it's designed in a way where you don't have to explicitly say it. You can just chat it, and it's going to extract this information from conversation. Any relevant or personalized or important information, and put it in your what do you call this? In your data sources like GraphDB or vector store.
Got it. And then we have the actual places where so far we have the LLM, we have the agent, the prompt, the tools that agent can use, right? And then the data sources, right?
Yes.
And so for us, we have decided to go with a normal vector store, which is how people do retrieval augmented generation with like normal embeddings. We've
Yes.
decided to use a graph rag database as well, which adds some additional metadata around those embeddings to form associations between the embeddings a little bit better, right?
Yes.
And then we're using Google Cloud Storage as a document store that the agent can search and retrieve information or documents that we've given it to also help with the memory, correct?
Correct.
But you don't have to use those. You can get rid of one of those if you want. You can swap something else in if you don't want to use. We're using Google Cloud Storage, Supabase for the normal vector embeddings, and Neo4j for the GraphRag database, correct?
Yeah.
And these are all open source and ownable. Well, Google Cloud Storage obviously isn't, but you can move your documents between different storage providers. Supabase and Neo4j are both open source, right? And so you can host with them. You can host them on your own computer. You can host them in the cloud hosting provider of your choice. So you have, excuse me, this ability to swap those things in and out. And then as we move forward in the future, because of the way you've added it, if we want to add other things, other data sources, that's just as simple as adding another tool that can work with that data source and adding that data source as one of the data source that the agent's calling upon when it's managing the memory, correct?
Yes.
Great. Cool. What
Mm.
else? What else will we want developers to know about this that are checking out the GitHub?
Okay, so the next customization that they can do. So we discussed, again, I will just give a quick sum here. We discussed about data sources, we discussed about the agent itself, and then third customization where they can customize, it's the way they interact with the agent. Because currently, and all the interactions between, it's like delivery of this agent or how you interact with this agent, it's stored here in this presentation folder. And presentation folder has different subfolders. It has users can interact with the agent via API. They can interact it with this line graph. It's empty for now. They can interact it with via web, and we use Streamlit for now. So the default option for us that we will deploy is using this Streamlit, and it provides the like very simple chat interface. You have side panel. On the side panel, you can log in and log out. Sorry, you can log out. And for logging in, we also use Google Sign In, and that's I think very simple interface for now. In the future, there will be other interfaces here. We can add it also interacting with agent using CLI command, like PowerShell or terminal from Mac or Linux. And that's basically what we will also add the MCP server. This is another point of interaction.
Great. All right. Anything else you'd like developers to know that are checking this out?
Yes, what we discuss here, we have here this docs file. There is architecture. Uh, uh, they can read about. There is configuration file that what they can config, what environment variables they need to provide. There is installation instructions here, and there is just general user guide. And this user guide is good enough for tech people and non-tech people. Anyone can read. It gives a good summary in terms of what this app can do, what types of query you can ask, and that's it. And other interactions like uploading documents, how it's going to work.
Great. And what would be good? What are we looking for from developers on our side? Obviously, they can use this however they want. It's MIT license, it's built on open source software, et cetera, and open libraries. So if they just want to take it and run with it and have a nice day, that's fine. But how could they help the project succeed?
Okay, first they can, in terms of contributions, we can, okay, let me think. I think in terms of contributions, it will be data sources and also the presentation, because this is like if you think what's the core like value or core business, what the core business logic is the agent itself. I don't think it's going to be changing, but what could change is the data sources that this agent can work with, and also the presentation. So that's 2 points or two main areas that we can that anyone can contribute to this.
Okay, so data sources, if you have a data source that you want to add to your memory, and you create
Yes.
something for yourself. If you're open to having other people use that same integration, contribute it to the project, and we'll add it to the list of data sources that people can use with this when they're building and managing their memory for their AI system, right?
Yes, correct.
And then the second thing on presentation, what do you define that a little bit better? What do you mean by presentation?
Presentation, it's basically where we, uh, I got the name because of, I named this folder because of it's the way you present your agent to the user, and you can present, we can call it interaction, but it's basically the interaction point between the user and the agent itself. And so currently, as discussed, we can use it as a, sorry, we provide with a web interface. It's
Oh, I
here.
see. This is the front end. This is basically how you interact with this memory agent. Whether right now it's Streamlit, which is a web-based user interface for chat. We want to add, as we improve the BrainDrive interface, we want to add that. So if there's other interfaces that people are using to get this in front of a user, we want to add those here under presentation. Yeah.
Yes.
And then there's MCP server, there's an API that we're developing to be able to hook it in via API, et cetera, right?
So there is already a basic API in here, and currently it has only these two endpoints, add text or search. And further, we'll also add the streaming endpoint, which is the actual way of interacting with this agent. And we also have this LangGraph routes, and it's I don't know if anyone wants to use it. It's basically dependent on this LangServe, and it's from LangGraph. It gives you a nice interaction with it's like a diagram. Somehow they identify, because we use LangGraph AI library. They show you how your agent is structured, and this agent. Well, when I'm talking about this agent, they show you this implementation in diaphragm form. So now you can see it as written in the code base. But if you use this line graph routes, they show you the diagram, and also they have this interface where you can interact with it. So there is another one that is good for only for debugging, not for production. But for developers, it's good enough. If they somehow or for some reason they want to change the behavior of this agent, they can do it using these line graph routes.
Cool. And what is different about this system than other things that are available out there right now for people to try and add memory into an AI system?
Okay, first, the difference here, of course, we are using this RAG technique here. That's the main point. We use this RAG technique, but this app is not designed on it's not designed on agent. Yes, the agent itself, the agent that we built, it's the main one of the main logic there that puts all these pieces together. The main idea is designed on top of data sources. So you have your data sources, and what it means your data. You have your data. At the end, you can have the same interaction with ChatGPT. You can have same interaction with Gemini. You can have any interaction with any other RAG platforms or AI platforms. You can have same interaction. The only missing piece there is that you don't have this access to your data. With what we have now, you build your data, and it's designed to build you're mimicking. This data contains all information about you, about your business, about the way you communicate. All these interactions are stored in your data. So this is like the first step or fundamental idea. So you have your data, then you have this agent, which is very important because it decides what needs to be stored. It decides how it needs to be, the communication between you and these data sources. So to sum up, at the end, you interact with this agent. It serves as a helpful assistant, and you're building your digital brain. You're building your database, which is all about you.
Right. And you own and control it, right? Like you're not offloading the ownership and control over the memory of your AI system, and then you're stuck with whoever owns that, whether that be Gemini or ChatGPT, and as they build more memory around you, that tool's going to get more and more useful, and you're going to be kind of locked into that tool, or your information is going to be spread out all over the place across all these different tools, which makes it a lot less useful. So this gives you the ownership and control um, over your memory, and so you can use your memory with whatever AI tools you want to use it with, and not have to worry about being locked into one specific tool only, or having your data spread out all over the place. Correct?
Yes,
And
correct.
and we looked around for open source systems that do this type of thing and struggled to find anything that would work how we wanted it to work, correct?
Yes, we found many tools that basically they're built on top of RAG, and they build on in terms of, okay, you have your documents and there is an easy way to chat with your documents. Our system does this, but it's not designed because of that thing. It's designed because you are building your digital brain. It stores your data. That's the main difference between others. Yes, we use RAG technique to retrieve this information and answer your questions, but it's not the main point. The main point here is you have, at the end of this interaction, you get your data and it's with you.
Right. And it's so built in. What's we're doing the chat with your documents thing that everyone's doing. We do that too. But this system on top of that also is building, maintaining, and editing your memory system, these databases, these graph databases. It's up constantly updating and changing the information in there based on your interactions, just like your physical mind does when you're having interactions throughout the day. So, some information like how old you are is never going to change or update, right? Well, it will as you age, but when you were born is a better example, right? Other information like, if you're not married, who you're dating at any one specific time, that's probably changing, and that type of thing. So, this system is designed not only to, it's designed to be kind of a two-way street of information, updating this memory system and getting better and better at responding to your questions over time, and also being more and more helpful. So, for example, once I tell this system that I'm a vegetarian, it should remember that going forward. And therefore, when I ask it things like, can you please give me some restaurant recommendations in my town for this weekend? It should automatically be recommending things that are vegetarian friendly. And similarly, if I change my mind in the future and become a meat eater, um, I should only have to tell the system once that I'm no longer a vegetarian, I'm now a meat eater, and it will then incorporate, non-vegetarian options into those same restaurant recommendations. So that's really the key difference here. Another key difference I would say is there's no lock-in here, right? So the fact that you can swap things in and out, the fact that all of this is public MIT licensed code that we're doing, right, and it's built on open source technologies, for anything that we're not doing, we're not. It's very important that not only do you have ownership and control over this memory, but that you're not locked in to any one system or set of technologies, et cetera. And so we've really tried to construct this in a manner where there's no lock-in of any sort around your data. You're always in ownership and control over it, and can move and add and subtract as you please, right?
Yes. True.
And where I think a lot of the best memory stuff out there right now, because they're trying to build businesses off of the old way of doing things, which is to lock your data in, they lock your data in, and that's going to be their competitive moat over time. So, tools like ChatGPT, the more that they learn about you, the more useful they're going to be, which is going to be a great thing, but also the harder it's going to be to move from that system to another system because you don't own and control that memory. And this process is not as simple as just exporting all the chats that you've done over a period of time. There's a lot of other connections between this data that are built up and updated, et cetera, the more that you use it. And really moving off of a system in the future like ChatGPT is probably going to be like having brain surgery. It's like you can do it, but you don't want to.
Yes, true. Yeah, now this like chat interfaces like ChatGPT and Anthropic, I think they have this option where you can export these chats. Yes, this is true. You can export the chats, but here, as we said, we have graph database and vector store. Okay, vector store is it just stores data normally, and there is no connections. But in graph database, the whole point of this, why we integrated this graph database, because it's close to the to the brain in our body, how the brain works. You have this one piece of information, and it's like a neural link. Same true for this knowledge graph. It builds this, it extracts the entities and then identifies how these entities or pieces of information are connected to each other. So it builds this. It's that I think this term of digital brain is explains the whole purpose of this thing.
Yep. All right, great.